Oh, the Japanese candy,
What
huh?
the one you said you were gonna bring me?
I typed it.
Well,
Because you took like half my bag.
I took the 3 pieces.
You did not take 3 pieces.
thank you for the Japanese candy. I will definitely appreciate it.
Taxes, Megan. In fact, you
So,
only can.
I'm already recording it, so thank you for being my guest.
Oh.
Yep. So here we're looking at the graph of f prime. We know it's continuous. F is continuous, eh? We don't know what f looks like. We know it's continuous. The graph of f prime is shown. Which of the following intervals is f increasing? I mean, for f to be increasing,
Let's be great.
what has to be greater than zero?
The, the first one.
The derivative has to be greater than zero. So basically, that means that this first segment from 0 to 2, that's the answer. It's the only one that says 0 to 2. Also from 4 to 5, though. Like here, positive. F of x is increasing because the derivative is positive. Yep. Okay. B, or it's not B, 77. The height of an object at time t is greater than or equal to 1 is given by h of t. What's the velocity? So that means we have to take the derivative. And just remember that this 16 over t, that's t to the negative 1, right? So then my derivative here, is going to be 2t negative 16 times negative 1, and then subtract 1 from the exponent. Before I do anything with it, let me clean it up. 2t plus 16 divided by t squared. Now just plug in 3. Yeah.
Couldn't you just plug this whole thing into the calculator and get it right off?
Oh, you're right. This is the calculator portion. Yeah, you don't have to do it by hand. Thank you. You could do math 8. Math 8. Plug in the equation, but you have to plug in h of t. It'll be d dt of h of t. I forgot that this was the calculator portion. Evaluated at t is equal to 3. Exactly. And then, I mean, I'm going to get it by hand too. What are you getting? Okay. And mine makes sense too because it's 6 plus a little bit more. So B. Yes, it is the calculator portion. Don't waste your time doing it by hand. I will. I can just sign. The function g is differentiable. We're given that g of negative 1 is 4. G prime of negative 1 is 2. What is the approximation of g of negative 1 using a tangent line? What do we need to make a tangent line? We need a point. Mm-hmm. And we need slope. So here's my tangent line. Y equals m, x minus x1 plus y1. They already told me the slope. Slope is 2. X is negative 1. And y is 4. Now they want me to use my tangent line to approximate negative 1.2. So I'm going to plug in negative 1.2. I'm also going to clean up the negative 1 minus 1. And like we said, it's a calculator question. So if you want, just plug it all in or finish it by hand. Either way, it's doable. Because this would be negative 0.2. It would be negative 0.4. So then it's 3.6. Okay. Next one. And if at any point you have a question, let me know. 79. Tara's heart rate during a workout is modeled by the differentiable function h. Okay. It's measured in beats per minute. So that's already telling me that it's a derivative. Which of the following expression gives the average heart rate? If average value, if this equation is the heart rate, the average heart rate is going to be 1 over b minus a times the integral from a to b of her heart rate. B. Okay. Okay, we have a derivative. We have a condition. What is g of 5? I'm always getting asked questions about how to do things like this. You gotta remember the general formula. The general formula here, if you want to find the value of a function, you're gonna have to integrate the derivative. And then you also have to include an initial condition. This has come up a lot. Sometimes you do it by hand, not in this case. This is just general, right? Because technically we're dealing with g's. So if I want to find g of 5, I'm going to do the integral up to 5. Do I have a derivative? Yes, I do. Then my initial condition. I'm given that at x is equal to 2, the y value is -7. Just plug it in the calculator. Plug it in the calculator even if the limits of integration were out of order. The calculator will do everything for you. The answer is C. F is a function that has a removable discontinuity at 3. Which of the following could be the graph of F? This is a jump discontinuity. This is a jump discontinuity. This is an infinite discontinuity. Infinite. C. You could do what I'm doing. Yep. Okay, 82. F is a continuous function. We have all these little conditions. What is the integral from 0 to 13? Okay. Well, if I take the integral from 0 to 17, and I add the integral from 7 to 20, sometimes the best thing to do is just kind of start working. That's going to be 8 plus -3. That's going to be 5. That technically is the integral from 0 to 20. Okay. Now, from 0 to 13, well, think of this as a number line. If I already know the integral from 0 to 20, and I also know, and it's 5, and I'm also given this guy, and I just kind of like remove it, I'll get the integral from 0 to 13. So here it is again. Once my computer stops lagging. If I want to find the integral from 0 to 13, and I already know the integral from 0 to 20, and I subtract the integral from 13 to 20, then that's going to give me my answer that I want. So from 0 to 20, it's 5. From 13 to 20, it's -3. So it should be 8. Whoa, I missed something. What was that? From 0 to 20, it's what? 13 to 20 is 7. Oh, thank you very much. Good catch. 13 to 20 is 7. See, I'm glad I have you guys. And the answer is, in fact, -2. Mhm. Good catch. F is the function defined above. K is a positive constant. What's going to make the function continuous? What value of K? So, what needs to happen for a function to be continuous with the left and the right hand limits? They need to be the same. Whatever the graph is, they need to meet up. And it needs to be filled in. The left hand limit must equal the right hand limit. If you want to be really, really professional, you would do this. The limit as x approaches 3 from the left of f of x equals the limit as x approaches 3 from the right of f of x. You don't have to write that. It's multiple choice. I'm just giving you like the most formal way of doing it. Technically, you just got to plug in 3 into your equation. K to the power of 3 plus 3 equals 16 divided by k squared minus 3. Graph it with the calculator. Find the point of intersection. Yep, you would get 2.081. Graph it and find the point of intersection, or subtract the 16k squared minus 3 and then find the x-intercept. One or the other. Find point of intersection or find the 0. Whichever way you prefer. But yeah, it's this one, right? You said 2.081. Okay. 84. The table above gives values of a continuous function based on the information which statement must be true. F has at most 1 0. We don't know that. We have no idea what the function is doing, right? I'm going to say no, because even though at -5, you're at -9, at 0, you're at 1, and at 2, you're at 5. I mean, we're being told that the function is continuous. We're not being told that the function is strictly increasing. So for all you know, it could be doing this. So no, it's not going to have at most 1 0. F has a relative maximum at 2. No, because it could do this. Again, we are not told that the function is strictly increasing. We're told that it's continuous. There's going to be a value C where you hit 4. Yeah, that's the intermediate value theorem. Because no matter what the function does, okay, me pasé poquito, but at some point you must hit 4, right? And there's no way around it. You're gonna have to go through 4. That looks like the answer already. There exists a value C where the slope is 2. They never said the function was differentiable. They never said it. So no, that's kind of implying the mean value theorem. But again, the condition of differentiability must be there. And maybe that is true. They're trying to trick you because look, y2 minus y1 divided by x2 minus x1. That's going to be 14 over 7. The average rate of change is 2. Which is going to lead you to think, hey, maybe the instantaneous rate of change is going to be 2. But all the conditions were not there. The function f is an antiderivative of the function g. Which of the following is the x-coordinate of the local maximum? F is the antiderivative of g. F is the antiderivative of G. In other words, F prime is G. So technically we're looking at F prime right now. If you want to find a local maximum, graph it. Graph your G of X because you're looking at a derivative already. Did I give myself a little sketch of what it looks like? I think I did. Should look something like this. This is a local maximum. Your derivative is going from positive to negative, which means you're going from increasing to decreasing. So that is your local max.
It's so easy, but I don't think that.
Hopefully you will by the time we take the real one. We still have 2 weeks of review, and one more practice test. Okay, 86. The graph of f of x is shown. Which of the following could be the graph of the derivative? A derivative tells you when the function is increasing, right? When f is increasing, f prime should be positive. So from 0 to 2, the function has to be above the x-axis. Oh, come on, computer. There we go. So it's not C. Okay. From exactly negative below the x-axis. It takes away which one? Correct. B. From 2 to 3, we are below the x-axis.
No, but it has to go past on top by 3, down goes on beyond 3.
Oh, because you're saying that from 3 to 5,
Yeah, it's positive, so it has to be above.
it has to be above,
And 3 goes beyond 3, so it can't be that.
and this is still below. So then there's your answer.
Think about the other side.
Good catch. You were, steps ahead of me. 87. From 0 to 2, the velocity of a particle is that. B is the time when the particle changes directions from left to right. What is the total distance traveled by the particle from 0 to B? Okay, so we got to do two things. First, you have to graph it, because we need to figure out when the particle changes from left to right. And also keep in mind that we're looking from 0 to 2. Did I give myself a sketch of what this looks like? The graph, your corrections need to have sketches. Because like if I'm the expert and I'm doing that, why wouldn't you? You're the ones learning. So this is really helpful for me studying. Now that I'm reviewing this, I don't have to go through all that work again. So the graph kind of looks like this. I'm gonna call that first critical point A and this one B. When does the particle change directions from left to right? At A or B?
It's a change direction, so the
The particle, we're not looking at area, we're looking at when does the particle change direction. The particle was moving left and now it's moving right. And of course, this is velocity. And the question says, when does the particle change direction from moving left to moving right? It's B. It has to go from negative to positive. At B. Whatever that is. You find it with your calculator. B is 1.845. Now you want to find the total distance traveled from 0 to B. Make sure you put absolute value. And that would be, let's see. Okay. 3 more questions. Here is f of x. For how many values of x is the instantaneous rate of change equal to the average rate of change? Okay, luckily we have a calculator. You need to find the average rate of change. (1.565 minus 0). And that's going to equal to the instantaneous rate of change. My derivative is going to be x to the power of 3 minus 2x to the power of 2 plus x minus 1/2. According to my work, the average rate of change is negative 0.392. Graph it, figure out when this happens. But you're looking for answers between 0 and 1.565, right? Not beyond that. There's going to be 3 answers. I'll tell you what they are. It's 1.1289, 0.56, 0.1492. When you graph it, you can do 2 things. You can graph both functions. I didn't do a sketch of what it looks like, so I'm just going to make it up. You're going to graph the derivative. You're going to graph the negative 0.3, and you would see 1, 2, 3. And then, like I told you earlier, you could also kind of just move the 0.3 to the other side. And then figure out the x-intercepts. Whatever's easier for you. Whatever's easier. Find the zeros. Usually this one's a lot easier because your calculator should always be set so you can see the x-axis. But sometimes the points of intersection happen at weird places. So trying to figure out where 2 graphs cross could be a little tricky. So this one is always really, really good. 89. G is a twice differentiable function. We know it's increasing. We know it's also concave up. We know that G of 3 is 12 and G of 5 is 18. Which of 20, 21, and 22 are possible values for G of 6? If you think about this in a linear way, it's increasing by 3. Exactly. 3, 12, 4, 15, 5, 18. So is the answer 21? Because you're only thinking about increasing. You're not thinking about concavity. What my linear sketch has no concavity. So when something is concave up, oh wait. Yes, we are increasing. But maybe it's like this. Right? If we continue with our linear approach, this would be 621. But when something is concave up, it will eventually grow faster. So that's why it's not, first of all, it's not 20. So we can already cross that one off. So It can't be 21 because that was a linear approach where the concavity was 0. G double prime of x was 0. That's what gave us 21, right? Because it was plus 3, plus 3, plus 3. But it's not that one, so it can't be 21. And if it can't be 21, then the only answer possible here is 22. The table gives values for a differentiable function f and its derivative at selected values of f, x. G is the inverse. Which of the following is the equation of the line tangent to the graph of G at the point x equals 2? If G, what's G of 2? They are inverses.
Oh, so you could,
You had it right, and then you convinced yourself of the wrong one. You were about to say it earlier. You might have even said it.
I want to see 3, but
Yeah, and then you convinced yourself of the wrong one.
oh goodness, I'm gaslighting myself.
Because if f of 3 equals 2, then the inverse is that g of 2 is equal to 3. You overthought it. You had it, and then you overthought it, and you picked the wrong one. So then don't overthink it. It's simple. We also have to find the derivative. There's a formula. I kind of always forget it, so I always derive it. Since the functions are inverses, I know that f of g of x is going to equal to x. That's always the case with inverses. You take a function, you plug it into the inverse, it cancels everything except x. Then I take my derivative. Just as long as you do your chain rule correctly. Then you plug in your value of 2. Notice how g prime of 2 is isolated. I'm going to be able to solve for g prime of 2. So g of 2, we already know that it's going to be 3. And f prime of 3 is 5. Which means the slope is 1 over 5. So my tangent line is going to be m times x minus x1 plus y1. Do they have it in this format? They do have it in this format. There we go. That's, yeah, thank you for making me do the video. Hopefully when you watch it, you're not distracted by all the side conversations because they're kind of talking pretty loud. Yep. All right. Well, let's keep going, guys.